Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, I'm going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico series, lesson number 7. But since that wasn't really a homework solution that's worthy of a video, the only reason I'm doing a video is because after the fact, I thought about a better way to do lesson 6. And so I thought, why not combine the two? We'll talk about what's wrong with lesson number 7, and then go back and look at what's wrong with lesson number 6. So to answer Paul's question, what went wrong in the code that he presented to us? Well, what's happening here, if we walk through the code, it's deciding, okay, if the value is less than 80, we're going to turn green on, we're going to turn the other two off. If it's greater than or equal to 80, we're going to turn green off and turn yellow on and keep red off. And if it's greater than or equal to 95, we're going to turn off green and yellow and turn on red. Well, if you notice what's happening here, if I send it a value of, let's say, 96, we come down, is 96 less than 80? No, okay, so we skip that. Is 96 greater than or equal to 80? Yes, it is. So we're going to turn on the yellow LED. Is 96 greater than or equal to 95? Yes, it is. So we're going to turn off the yellow LED and turn on the red LED. And the result is we start to see a flicker. And what's happening is every time through this loop, it's briefly writing yellow as on, then writing it off, and then writing red as on, and then going into the 100 millisecond sleep. So that's why we predominantly see red, but we keep seeing this slight flicker in the yellow LED. And I've highlighted it with an arrow, but if you watch the video closely, you'll see the flicker as well. So the reason that this is a problem is because we don't want it flickering. We want it, if I set the potentiometer to 96%, I want to only see the red LED. I don't want to see the yellow flickering. So that's the answer to Paul's question. But I was wondering, is there a better way to do lesson 6? Because one of the things that I did in lesson 6 that I shouldn't have done is get ahead of class and use what are called compound conditionals. Paul's going to teach us these in a future lesson, but I used compound conditionals because that way I could say between this and this, do this, between this and this, do this. It got me thinking though, is there a way we can write this code better in a way using only the things we've learned so far in class? And as it turns out, yes, there is. So I've started off with basically the same code that I used in lesson 6, which is bringing in my modules, setting up my pins, setting minimum and maximum for my potentiometers. I did change my thresholds. Last week I used 81 and 95. This week I'm going to use 80 and 84. I think that works a little better with what I'm going to show you. So then we get to our true loop, and the first thing we do is we read in our pot value, and again, I'm going to set that low boundary and that high boundary. The low boundary, if it's less than 300, make it 300. High boundary, if it's more than 65, 530, make it 65, 530. Then I come here and I use my y equals mx plus b equation to, this time I'm going positive, so I want my y-intercept just slightly below 0 with a slope of with the positive slope from 0 to 100 throughout the entire range. But we're going to do something a little different. We are going to, instead of writing out the status, or I should say writing the value to the LED every time we run through an if statement, I'm going to use a variable. And I'm going to say my state of that LED, I'm going to start off with 0. They're all off. Then I'm going to say, okay, if it's greater than 0, meaning it's on in some fashion, I'm going to turn on the onboard LED because, again, I'm using that as kind of a power light. Here, let me flip back to that. I'm using the onboard LED as a sort of power light. Regardless of what the value is, this light is going to be green if it's greater than 0. And we assume that we're green if we're greater than 0. So I've set the green state to 1. Then I say if it's greater than threshold yellow, which is 80, so in this case 81, I'm going to set the green LED state to 0, the yellow LED state to 1. And if it's greater than red, I'm going to set the green and yellow states to 0 and the red state to 1. Notice that this has a very similar flow to Paul's code, except that we haven't actually told the LEDs what to do yet. All we've done is written some variables out. So now we're going to come down here, we're going to print that %, and then we're going to actually go LED by LED and say we're going to write out the variable. So let's say that our value is 96. Well, our value is 96, so is the onboard LED on? Yes, so we're going to write a 1. Is the green LED on? No, so we write a 0. Is the yellow LED on? No, so we write a 0. Is the red LED on? Yes, so we write a 1. And then, of course, we go into a sleep loop. That's just to keep the console from flooding. And so if I run this program, and I start to bring this up, notice the power light and the green light go on as we start to increase our percentage. And as we break 80% here, which we will shortly, there, now the yellow light is on, and notice it's only the yellow. We're not getting a flickering of the green or the red. And now if I break up here to 99 or 100%, you'll notice the red LED is lit, the green power LED is lit, and there's no flickering in the yellow and the green. So I thought that would be something neat to show. Just another way of doing lesson 6 without using compound conditionals, without using things we haven't learned in class yet. So if you like this video, hit like and subscribe below. I appreciate it. And thank you for watching. This is Brian from Simply Brian Enterprises, and I will see you next time.